Hi, I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about the types of optical fibers, which is in the module 3. So, here in this topic, we are going to cover modes of propagation, step index optical fiber, graded index optical fiber, single mode optical fiber, multi-mode optical fiber, and then differences between the step index and graded index optical fibers. Then we see what are the reference have been verified. So modes of propagation. Modes of propagation. So light propagates as an electromagnetic wave through an optical fiber. Okay, all the waves having ray directions above the critical angle will be trapped within the fiber. Here the light is propagating as an electromagnetic wave through the optical fiber. So here what are the waves propagating having ray direction above the critical angle? They will be trapped within the fiber. But in real, only certain ray directions are allowed to propagate. The allowed directions are correspond to the modes of fibers. So here, in real, only certain ray directions are allowed to propagate. The allowed directions are which are correspond to the modes of optical fiber. So light ray traveling through the optical fiber are classified as axial rays and zigzag rays. As a ray gets repeatedly reflected at the walls of the fiber, phase shift occurs. Consequently, the waves traveling zigzag path will be in phase and intensified, while the waves coursing along certain other paths will be out of phase and diminished due to the destructive interference. So, here the waves traveling zigzag path will be in phase and they are intensified, while the waves coursing along certain paths will be out of phase and diminished due to the destructive interference. The light ray paths along which the waves are in phase inside the fiber are known as modes. So, the light ray paths along which the waves are in phase inside the fiber are known as modes. The number of modes that a fiber will support depends upon the ratio d by lambda, where d is the diameter of the core and its wavelength of the wave being transmitted. So the number of modes that a fiber will support depends upon the ratio d by lambda, where this d is the diameter of the core and lambda is the wavelength of that light which is transmitting. Types of optical fibers. So based on the variation of refractive index of core of an optical fiber, fibers are classified into two types. As we have seen in the previous session, the construction of optical fiber. So in the construction of optical fiber, there is three main parts. One is core, another one is cladding, then surrounding cladding there is buffer jacket. So like this, the optical fiber. So the inner layer is the core and surrounded core there is a cladding. This cladding is surrounded with buffer jacket. So this buffer jacket is used to protect the optical fiber, that is, it protects the core and cladding. This optical fiber works with the principle of total internal reflection. So that total internal reflection happens between the core and cladding. So this buffer jacket protects this core and cladding. So here when taking core and cladding, regarding N1 and N2, that is refractive indices, N1 is greater than N2. So these core and cladding refractive indices, or N1 is greater than N2. So depending upon the refractive index of the core of an optical fiber, these optical fibers are classified into two types. So one is step index optical fiber, another one is graded index optical fiber. One is step index optical fiber, another one is graded index optical fiber. Again, based on the number of paths, that is modes, the light rays inside the core, these optical fibers are furtherly divided into two categories. So again, based upon the variation of the core, based upon the variation of core's refractive index, optical fibers are classified into two types: step index optical fiber, graded index optical fiber. Again, taking the number of paths, that is number of modes available for the light rays inside the core, this optical fiber furtherly divided into two types, that is single mode optical fiber and then multi-mode optical fiber. Single mode optical fiber and then multi-mode optical fiber. So what is single mode and multi-mode optical fiber? In single mode optical fiber, the width of the core or the diameter of the core is smaller when compared to the width of the cladding. As a result, only a single path is available for the light ray to travel through the optical fiber. So in single mode optical fiber, the width of the core is smaller than the width of the cladding. So because of that type of construction, only a single mode can be available for the light ray to travel through the optical fiber. When the width of the core is greater than the cladding, then large number of paths be available for the light ray travel through the optical fiber, and it is known as multi-mode optical fiber. So in single mode, the diameter of the core is smaller than the diameter of the core. This is for single mode. So cladding, this is core. So this diameter of this core is so in single mode, width of the core is less than the width of the cladding, so that only single mode be available for the light through the travel through the optical fiber. In multi-mode optical fiber, The width of the core is greater than the width of the cladding. So, in multi-mode optical fiber, the width of the core is greater than the width of the cladding. So, in such case, the number of modes, large number of modes can be available for the light ray to travel in the optical fiber. Step index optical fiber, refractive index profile. So, in a step index optical fiber, the refractive index of the core remains constant throughout the core and decreases from step N1 to N2 at the core cladding interface. Thus, it is known as step index optical fiber. The transmission of information will be in the form of signals or pulses. So, here in step index optical fiber, the refractive index of the core, that is N1. So, refractive index of the core is N1. N1 this remains constant and it is decreasing from N1 to N2 at the core and cladding interface. So throughout this core, the refractive index N1 is constant, but where it is decreasing, so it is decreasing at the core and cladding interface. This is N2. So at the interface here, there is a step change in the refractive index of the core, that is at the cladding N1, N2 interface, that is core and cladding interface. There is a step change in the refractive index of the core. So in a step index optical fiber, the refractive index of the core remains constant throughout the core and decreases from step N1 to N2, N1 to N2 at the core and cladding interface. So that we call it as step index optical fiber. So in the step index optical fiber, the transmission of information will be in the form of signals or pulses. This is the cladding. Here a step change in refractive index. That is to N2. Step change to N2. For a single mode step index optical fiber, here we have seen what is step index optical fiber. Now in step index optical fiber, we are going to see the single mode step index optical fiber. For a single mode step index optical fiber, a single light ray from the signal enters into the fiber and traverses a single path and forms the output signal. In this case, two signals match with each other. That is input signal and output signal. Here, in this single mode step index optical fiber, single light ray from the input signal enters into the fiber. This is the fiber. That this is the cladding refractive index N1. This is core refractive index N1, cladding refractive index N2. So N1 is greater than N2. So when we see this refractive index profile, here core refractive index, there is a step change. That is N1 remains constant throughout the core, decreases at core and cladding interface like this. So here the input signal enters into the fiber, that is single light ray, single input signal is entering into the optical fiber and it traverses in single path, single path and forms the output signal. Okay, so in single mode step index optical fiber, we have the light ray will be traverses in a single path, so that the input signal which is entering into the fiber will be matched with the output signal. So the input signal and the output signal both are matched. So two signals match with each other in the single mode step index optical fiber. Coming to the multi-mode step index optical fibers, due to large width of the core, greater number of light rays from the input signals enters into the core and takes multi-paths Suppose the light ray 1, which makes greater angle with the fiber axis, suffers more reflections through the optical fiber and takes more time to traverse the optical fiber. Whereas if we take the light ray 2, it makes less angle with the fiber axis, it suffers less number of reflections, and within a short period of time, it traverses through the optical fiber. So at the output, we receive ray 2 at first and later we get ray 1. Due to the path difference between the light rays, when they superimpose to form the output signals, the signals are overlapped. So in this, we get signal distortion known as intermodal dispersion. It is difficult to retrieve information carried by the distorted output signal. In a step index fiber, the propagation of light ray is due to multiple reflections. So it is of a reflective type. So we can see here multi-mode step index optical fiber. The width of the core is greater. So that a greater number of light rays can be entered into the core. So that more number of light rays enters into the core and takes multi paths. Suppose I am taking more 2 rays. So this is the core and so because of larger width, the core width is large, so that more number of light rays can be entered, like that. More number of light rays can be entered, so that they may face multiple paths. They may get multiple paths. Here we are taking two rays, ray 1 and ray 2. So ray 1 makes greater angle with the fiber axis. It suffers more reflections. So due to that more reflections, it takes more time to traverse through the optical fiber. When taking light ray 2, so this light ray 2 is entered with less angle with the fiber axis, so that it suffers less number of reflections, so that within a short period of time it traverses through the optical fiber. So here it takes much time. Here light ray 2 takes less time, short time, so that this ray 2 within the short time we can see at the output, and then secondly, because of more number of reflections, it takes more time, so that light ray 1 we can see later. We can see later at the output. So that there is a distortion because of there is the output is not coming at the same time. So that because of suffering of more number of reflections and taking more time, and the second one because of less angle and suffering less reflections and taking short time, so that light ray 1 comes first, light ray 2 comes later. So that because of that time, we are getting two output signals with different times, so that there is a overlap of signals. So here, due to the path difference between the two light rays, when they superimpose to form the output signal, the two signals are overlapped, so that we get signal distortion. So that signal distortion happening in the optical fiber is called as intermodal dispersion, so that it is difficult to retrieve the information which is carried by the distorted output signal. In step index optical fiber, the propagation of light ray is due to the multiple reflections, so that it is a reflective type. So here it is easy to understand through this diagram, multi-mode step index optical fiber. So here the width of the core is large. Width of the core is larger, refractive index is N1, and there is a step change at the interface of core and cladding. So here, as being larger width of core, more number of light rays can be entered. Multiple light rays can be entered into the core. Suppose there are two light rays entering into the core. So we are giving two input signals, signal 1 and signal 2. That is, this is light ray 1, this is light ray 2. So this light ray is making angle, larger angle. So light ray 1 is making larger angle larger angle with the fiber axis. This is the fiber axis. So light ray 1 is making larger angle with the fiber axis entering into the core, so that it gets multiple reflections, more reflections. Multiple reflections. And because of more reflections, it takes more time to come out from the optical fiber. And taking ray 2, this is making less angle with fiber axis. So ray 2 is making smaller wavelength, a smaller angle with the fiber axis. So it suffers less reflections. 1, 2, 3. Okay. So ray 2, which is entering with less angle into the core, it suffers less number of reflections, so that it takes a short period of time to give output signal. So that ray 2 comes fast as output signal, then light ray 1 as a second output signal. So when comparing to input signal and output signal, there is no match each other. That is, here we get light ray 2 as first, then light ray 1 second, so that two signals be overlapped here. So there is signal distortion called as intermodal dispersion. The number of possible propagation modes. So the number of modes available in the core is given by the V number, that V is equals to 2 pi by lambda A into Na. So where lambda is the wavelength of the light, A is the radius of the core, Na is the numerical aperture. So numerical aperture, light gathering ability of an optical fiber. So the number of modes through the step index optical fiber is equal to V square by 2. The number of modes available in the step index optical fiber is equals to V square by 2. Graded index optical fiber, refractive index profile. So in graded index optical fiber, the refractive index of the core decreases from the fiber axis to the cladding interface in a parabolic manner. In a graded index optical fiber, the refractive index of the core decreases from the fiber axis to the cladding interface in a parabolic manner. So when the light ray enters into the core and moves towards the cladding interface, it encounters a more and more rarer medium due to decrease of refractive index. As a result, the light ray bends more and away from the normal and finally bends towards the axis and moves the core and cladding interface at the bottom. Again, it bends in the upward direction, so that the light due to refraction takes sinusoidal paths, so that we call it as a refractive type of optical fiber. Refractive type of optical fiber. So in this graded index optical fiber, let's suppose when two light rays 1 and 2 making different angles with the axis enters into the fiber, they adjust their velocities due to the variation of refractive index, and comes to focus at the same point. So because of that, all the light rays will be received at the output end at the same time. So where in the multi-mode step index optical fiber, there the output signal is not getting at the same time because of the making larger angle and less angle, because of suffers more reflections and less reflections, and taking more time and then another one short time. So the signals are coming at different times, so that we are getting overlapped signal there in the multi-mode step index optical fiber. But here, when we are taking light ray 1 and light ray 2 with different angles with the fiber axis, they adjust their velocities. So how it can be adjust their velocities? Because it is made up with different refractive index. So due to the variation of refractive index, they adjust their velocities and come to focus at the same time as output. So as a result, all the light rays will be received at the output end at the same time. So there is no intermodal dispersion. That is, no distortion takes place here, so that no intermodal dispersion takes place. And the output signals match with the input signal. The output signal which is coming at the end will be matched with that input signal which we give. So it is easy to retrieve the information from the signals. So in this fiber, we get a refocusing effect of light rays. In this fiber, we can get a refocusing effect of light rays. So from this diagram, here the refraction, the core refractive index at the change in parabolic manner, so that it is like this, N1 and N2. So we are giving two light rays with different angles. So this is making a less angle, and another ray 2, it is making larger angle than the first one. So this is second one, this is first one. So larger angle is taking path in parabolic manner, and it is taking refractive path in this way, parabolic way. So like this. So the light ray 1 and 2 travels in parabolic manner in the core, and then the both light rays come at the end at the same time, so that how we are giving the input signals like the output signals also. So there is no mismatch happens here, so that all the light rays which are enters into the core with different angles comes at the same time without intermodal dispersion, so that we can retrieve the data from the signals, so that we get refocusing effect of light rays in the graded index optical fiber. The number of possible propagation modes in the core is given by V number. So V is equals to 2 pi by lambda into Na. where lambda is the wavelength of light, A is the radius, and A is the numerical aperture. So number of modes regarding to the graded index optical fiber, it is equals to V square by 4. So the number of modes through the graded index optical fiber is equal to V square by 4. Then coming to the differences between step index and graded index optical fiber. So when we see the differences between the step index and graded index, firstly, in step index optical fiber, the refractive index of the core remains constant and it is decreasing a step change at the cladding interface. So that refractive index of the core remains constant and decreases a step at cladding. In graded index optical fiber, refractive index of the core decreases parabolically from the axis of the fiber to cladding. This step index optical fiber is a reflective type. Graded index optical fiber is a refractive type. In step index optical fiber, signal distortion takes place. Signal distortion takes place, that is, there is intermodal dispersion in the step index optical fiber. So signal distortion is high in multi-mode step index optical fiber. Here in graded index optical fiber, signal distortion is very low. So that is, here we can say that no intermodal distortion takes place in the graded index optical fiber. In step index optical fiber, numerical aperture of multi-mode step index, it is high. Numerical aperture is high for multi-mode step index optical fiber, where here numerical aperture is less for graded index optical fiber. The focusing, no focusing of light takes place in the step index optical fiber, but here in graded index optical fiber, focusing of light rays takes place. So these are the differences between the step index and graded index optical fiber. So in this session, we have been covered the modes of propagation and types of optical fibers. In the type of optical fibers, we have seen the step index optical fiber and then graded index optical fiber. In step index optical fiber, we have again two types in step index and graded index, depending upon the parts, again divided into two categories, that is single mode and multi mode. Okay, so we have seen that what is a single mode step index optical fiber and is what is a multi mode step index optical fiber. Then how the refractive index profile is there in the step index optical fiber, how the light ray takes part in the optical fiber, how the input signal comes up at the end of comes as output signal. Is there any variation between the input and output signals in the step index and graded index? Okay, so and then we have seen the differences between the step index and graded index optical fiber. So in the next session we shall see with the other topic, and the references which I have referred in this for this topic is Engineering Physics 1, which is written by the K. Tyagarajan, publication is McGraw-Hill Education India Private Limited, New Delhi, and then a textbook of Engineering Physics, M.N. Avadhanulu, P.G. Kshisagar, and the publication is Chand and Company, New Delhi. Then Engineering Physics, Dr. M. Armugam, Anuradha Publications, Chennai, 6,70,000. And then one more textbook, which is named as Engineering Physics, P.K. Palanisamy, 4th edition, Scitech Publication India Private Limited, Chennai, 6,70,000. So these are the reference books which I have verified for this topic. So we shall see in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.